Yesterday we learned the equation F equals QVB. Okay? Now I demonstrated that this equation actually exists by having that wire passing through the magnetic field, right? And when I turned on the current in the wire either popped up, right, or fell down. Right?
Yes. Yeah.
So here I have some charges that are in magnetic fields, and these are two different situations. Okay? The magnetic fields are in blue, and the velocity vectors are in black. Okay? Now when we're talking about F equals QVB, we know that the force, velocity, and B field, or the magnetic field, all have to be what? All have to be perpendicular. What does perpendicular mean?
90 degrees.
Good. They make a 90-degree angle. Okay? Are there any questions about that? Okay. So, the question I want to ask you is, which way do each of these charges feel a force? Okay?
We don't know.
How do you not know?
In the middle.
All right. Let's go over our right-hand rule again. Okay? So, at the end of class yesterday, we talked about the right-hand rule.
After the bell.
Right? The right-hand rule.
Yeah.
The right-hand rule is where you take your
Trigger finger.
right hand, right? And there you use 3 fingers on your right hand, and you make this axis, this relationship.
Like this.
Okay? The way it works out is your thumb is the force, right? Thumb force. That's why I say it funny. Okay? So thumb is the force. Okay. Now your pointer finger, if I was playing cops and robbers, my pointer finger would be the one that I shoot my imaginary bullets out of, right? So that's the one. That's the way that the velocity points. That's the way the velocity of my imaginary bullets go. Okay, and you gotta make that noise. Pew pew pew. Okay. So thumb force, pointer velocity, and that means the bad finger is the magnetic field. All right. Bad finger, B field. Bad B. Bad B. You get it? Okay.
Wow, this is
So
Miss Thorin.
pointer
She always did this.
is the
What was
velocity,
the mitochondria thing that she used to do?
Okay.
No, this is what she said.
and the bad finger
Am I doing it right?
is the B field.
She used to make
Is it like this? Branch, is it like this? Or like this?
Ah, you're so funny.
No,
guys.
I'm for real.
Okay.
I'm not confused.
Make a cops and robbers gun.
Like this.
Yep. Then extend your bad finger.
Okay.
Make your right angle.
I'm not confusing.
Okay.
No, you asked me that.
So
No.
cops and robbers gun. Cops and robbers gun. Extend your bad finger.
What's on?
Okay. Does that make sense?
Yeah.
So now what we have created, guys,
Wait, what
Guys.
does the B stand for?
Right
magnetic
here.
field.
Right.
What we've created is the set relationship between forces, velocities, and magnetic fields. Does that make sense?
Yep.
Okay, Kyle, you have the wrong finger up there, buddy. If you need ISS, that's okay. That's what you're telling me right now.
What?
All right.
Why would I need
Now, this is called the right-hand rule because you have to use your
Why can't you-
right hand. So, left-handed physics students, you are at an advantage because you can write and use the right-hand rule simultaneously.
Oh, that's me.
Right-handed physics students, I guarantee one of you is going to try to write and use the left-hand rule. Okay?
They're wrong.
That's wrong. Okay? Now you're saying, why can't I use the left-hand rule? Well, let's look. Okay? So, my right hand, my left hand, right? If I look at the 2 rules, notice that both my pointers point towards you. Both my thumbs point up. But my my B field fingers, my middle fingers point opposite directions. Okay, you guys see that? That's why the left hand rule doesn't work. Right? Now if you could somehow bend your finger and go the other way with it, if you're double jointed, then go for it. Left hand rule all day long. Right? But you can't do it. If I turn like this, right? Now I've messed up my force, haven't I?
You
Right?
just go like this.
What if you go
Okay.
like this?
Just use the right hand. Okay. Mine's trying to figure out. You're left-handed. You like the right-hand rule.
Oh, yeah.
Okay. So, does that make sense?
Wait.
Guys, this makes sense. Any questions? Okay. Now, the right-hand rule, what type of charges do you think it's for?
Positive.
Positive. Good. The right-hand rule is only for
Left-hand people.
positive charges. Now, the left-hand rule will work for negative charges. But an easier way to think about negative charges is remember negative signs do what to our vectors? Negative signs do what for our vectors? Change them. So if I'm coming across a negative charge, you use your right-hand rule as if the charge was positive, and then at the end, you change the direction of the vector you're trying to find. Okay? We'll go through some examples of that. All right. So here, I have a proton traveling in a magnetic field. Will this proton feel a force? Why not?
It's going the same way.
Good. It's going the same direction as the B field. This proton will feel no force. Okay? Because what has to be true about velocity and B field?
Perpendicular.
They have to be perpendicular. So that proton will feel no force. So for this one, F equals 0. Okay. Does that make sense? Yeah. So if I want a proton to feel a force, one thing, Kyle.
What?
Which way does it have to go?
Down or up.
Up or down or
Round and round.
towards you or away. Any of which work, right? I'm going to say towards you. Now, why is that towards you?
Because you see the arrow.
Good. Good. It's the point of an arrow coming at you. You guys said you didn't remember from yesterday. Kyle, what's your question?
You got some tissue or something?
I do not.
I guess so.
Sure, you can go to the bathroom if you need to. Okay. So,
Thanks.
let's figure out no problem. Let's figure out the force felt. Are you sure you want to go to the bathroom though? You tried to change your vote earlier.
Thanks, Brian.
Hey!
Oh, Michael.
No, don't influence his vote. Do not influence Michael's vote. Don't say a thing.
Hey.
Okay? Michael, take a look. Okay? You are the deciding vote because Mr. Kyle Williams wants to vote and then try to change it. Alright? So, you get to pick. Alright? Not right now though.
What?
Okay. So, proton feels a velocity on the board, right? So, velocity on the board is towards you. So I take my pointer finger and I point towards you guys. Does this make sense?
Yes.
Okay? Or if I'm in your shoes, I'm pointing towards myself. Alright, I don't see you guys doing this. There you go. Or Whitney and Nan and Reggie and Jose and Caleb, you guys can point towards the back of the room. Okay?
This is kind of
Katrina, you can't because you're seeing the wrong orientation. Alright, so velocity is towards you, right? Which way is the B field? This one I'm not making.
Which way is west, though?
Okay. The B field is that way, right? It's actually south. Okay. The B field is this way. So my bad finger points this way. Does this make sense? So which way is the force felt by this proton? My thumb points up. So the force felt by the proton is up. So this proton will feel a force in that direction.
Brent.
Yep.
Can we take a class picture like this?
If you want to.
It's physics, though.
As long as you don't blow any circuits again. All right.
You
Any
have to do the
questions?
picture, and you have to do the same thing.
I don't know what that means. Okay. Any questions?
What does that mean?
It means
No.
basic.
Guys, any questions? Does this make sense?
Basic.
yes.
Okay. Let's say now I have an electron. It's in the same magnetic field as that proton, but it feels a force in this direction. Oh, that can't happen. Why can't that happen?
Because it's not perpendicular.
Not perpendicular to the B field. But it feels a force in that direction. What does that direction mean?
That's
Going
an X.
away.
You don't know that's
The X means it's going away. Okay? So if I want to figure out the velocity of this electron. Okay? Which finger's velocity? Pointer. So I want to figure out which way my pointer finger points when my bad finger points to the left, right? And my thumb points
To the up.
into the board because it's an X. It means the arrow's going away, right? So here's my right hand rule. Bad finger left, thumb into the board, velocity is up. If this were a positive charge, right? since this is a positive charge, since this is a negative charge, what do I do with my velocity? Flip it. So the velocity is down.
Wait, why?
Why
thought
is
it
it
would-
up? I thought it was towards you.
Yeah, I thought it was towards the board.
We changed.
I know, but since it's the x, it's going that way, so shouldn't the velocity be that?
No, the force is going that way.
Oh.
Force, velocity, magnetic field, all have to be perpendicular.
Oh, okay.
Okay? So if your velocity and your force are in the same direction, then it's not a result of
What if you go
magnetic
like
field.
this?
Then why was the dot the
Then
velocity?
you're wrong.
In this one, the dot was velocity, the dot because it means velocity is coming at you.
So it doesn't matter. It's what you label it.
Right. Any questions? Physics gang signs, nice. Any questions?
Get this.
Okay.
We should have put that on a shirt.
Here you go. Electron is traveling up in a magnetic field that is going.
Wait, did you make this up or did someone else teach you this?
Someone else made this up.
Oh, right.
Electron is going up in a magnetic field that is pointing into the board.
Oh, really?
Right? Remember, X's mean the arrow is going away from you, right?
I didn't know this.
So the X's are into the board, so the B field is going into the board, velocity's upward. I want to know which way this electron feels a force. Okay, hold on. Don't shout out.
Up.
Give everybody an opportunity. It's not up.
No.
Away.
Guys, stop shouting out answers.
I'll get it.
Quiet.
Right.
Okay, what are we trying to figure out here?
The force felt by the electron.
Which way is it?
That's dumb as
Which way is the force felt by the electron?
I'll go straight up.
Okay. So velocity is which way?
Up.
Up. So point your finger points up.
That
B
way.
field is
That way.
into the board,
To the left.
right?
Fine.
So point your finger up. B field into the board. My thumb points
To the left.
to the left.
Unless you meant
But
to-
the right hand rule is only for
Positive.
positive charges. Okay?
Damn.
The right hand rule is only for positive charges.
That don't even
So
work.
you use
Okay.
the left hand rule for negative.
So that means the electron goes which way?
Right.
Right. Left.
Wait, were
Left.
you recording?
Okay, yeah.
Down.
Sorry.
Yeah.
Left.
So B field in the board, velocity up, force is not to the right, it's to the
Left.
left. Oh, I said it backwards.
Yeah.
The thumb is to the left, since the electron it goes to the
Right.
right. Yeah, I
You're
can't
not
follow
gonna
that.
get video for
I get it
that.
now.
So,
You're not gonna get paid $100,000 a year by YouTube.
I know. The force is that way. Does that make sense?
Yes.
Any questions? Any questions?
Are we done?
Yes.
Okay, last one, and then we'll try some examples. A proton is in this magnetic field, and it feels a force in that direction. Is that a result of this magnetic field? Is that a result of this magnetic field?
No.
No, why not, Amani? Okay. Because if the magnetic field's into the board and the force is out, are they perpendicular? No. Okay? So that won't be a result of magnetic field. So let's try a different way. Let's say the force is that way. Which way is the velocity? Proton feels a downward force. Which way is the velocity?
Velocity. Towards. Wait. I don't know.
Right.
Velocity. What is the
It's
velocity?
gonna be in the board, right?
Oh.
It can't be on the board
Why not?
because the magnetic field is in that direction already.
That way.
Away.
Oh, that's my left hand.
I don't know how to do this. I'm getting tired.
Your hand's getting tired.
Yeah.
I'm getting
Won't play
tired.
rock, paper, scissors.
Mr. Branch, did you go to the graduation?
Did not grad class last night. All right, so which way does your bad finger go?
Oh, you're not going to my graduation?
I know.
The heck?
I will be done with grad school at that point.
Oh.
Okay. Which way is the bad finger? Into the board, right? Now this proton feels a force downward. All right. So bad finger into the board, force downward. Which way is velocity?
This way.
To the left.
Oh, I thought you.
Good job, everybody.
Okay.
So the velocity.
A lot of people.
There was a lot of people.
Does that make sense?
Yes.
Guys, any questions?
There were people in one section.
Okay. Reggie, Nan, take it easy. Okay. So
You brush on my teeth.
Your names are.
example 27.
Pick it out.
Guys, example 27. A proton is traveling left to right at 3 times 10 to the 6 meters per second when it encounters a 2 Tesla magnetic field pointing towards you. Okay? What is the force felt by the proton, and how would the force change if the charge were an electron? Okay? Now, drawing a picture is very important here. Right? So, we have a proton that's moving. Oh, that's not a momentum vector. It's my fault.
So driving left to right.
So moving left to right. So it starts to the left and it's going to the right. So that's the velocity, right? The B field is which way? Towards you. So the magnetic field is pointing towards you, right?
Yeah.
And we want to figure out the force. Okay? Now we know B is 2 Teslas, and we know V is 3 times 10 to the 6th meters per second. Right? And we want to figure out the force. So, the first step in figuring out the force, I guess it doesn't matter. You can do it in either order. I like to figure out the direction first. That's just how I roll.
Okay, teach us.
You know, using the gang signs, I figure that's how I roll. All right. So,
Okay.
oh come on, how does it lose?
BA.
All right. So B field points which way?
This way.
Towards you, right? B field is towards you. Velocity is to the.
The board.
Velocity is to the
Right.
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 Right?
Velocity to the right? Right.
Yeah.
Whatever.
Left. Velocity is going left to right.
B, so towards you, which is towards the board.
B towards you. Velocity to the right. That means the force is
Down.
down.
What? How is it down?
Because this is towards you. This is this way.
I thought towards you was
Yeah.
with the board.
No, towards you means you point your finger towards you.
Okay, wait.
So if I'm you, Nan, I'm pointing my bad finger towards me.
Why would I want to go like this?
How do we know which way the B one is?
How would
how do you
which
know
way-
if it's up like
Okay, how do you know? Because the V is to the right, right?
So if
So I can have a B field towards me in
I feel like
4 different
force is
orientations.
always going to be up. Like, you know what I'm saying?
but
Okay.
you have to do it downward.
Well, put your hand as if it's on the paper then. Okay, so if this is your paper, do this. Say, B field is towards me, right?
Wait, how do you know that though?
Because I have the dots. The dots means the arrow's coming at me,
Okay.
right?
But I feel like it's always up.
B field's towards me, right?
Yeah.
Velocity is
To the right.
to the right. Okay?
Force is
So that means the force is
down.
down.
To the right.
Okay?
Turn it.
Okay.
Your hand. No.
Turn it up. Okay.
Oh.
Have your physics book with the paper, with the whiteboard. Okay, so your B field's on the board, right? You got to your wrist like this, okay? Because it's coming out of the page.
Oh.
Okay? Now velocity is going left to right. So then you gotta turn it that way. So then your thumb is pointing this way.
Which way is the
Down.
Down the page.
Your thumb is just weird, so it don't look bad.
Okay, B field right. Velocity is that way.
That looks like towards you. Like,
So the thumb is down the page.
Over there, man.
Okay? I was trying to break your wrist, so hopefully. Alright, so the force then
It's fun.
is down.
Fun.
Okay, your thumb points down, so the force is down. Does that make sense?
Yes.
So over time, B field towards you,
I'm like,
velocity
gonna be up.
that way, thumb points down. Okay. So now let's figure out the magnitude of that force. So to find the magnitude, we use F equals QVB. So F equals Q, it's a proton, 1.6 times 10 to the negative 19, right?
Yeah.
Yeah.
V, 3 times 10 to the 6th. B is 2. Okay. So we can do that calculation, and we can
B
figure
is
out the
what?
force. What?
B is 2.
Yeah.
B is what?
Magnetic field strength. It's in Teslas.
Well, there's
So 1.6 e to the negative 19 times 3 e6 times 2, and we get
9.6 e negative 13.
Does that make sense?
Sure.
And it's Newton's Terry.
Hey, Terry.
Yeah, your bad vote might work out against you. Okay. Any questions?
I didn't vote.
Any questions?
Ask him right now.
Guys, does that make sense? Okay. Let's try the next one then. Kyle, stop talking. Trina, pay attention. Example 28. An electron traveling away from... Oh, sorry. We forgot to talk about which way it should feel the force. It was an electron. Okay? So since the proton feels a force down, the proton feels a force down, an electron would feel a force up, opposite direction. All right, 28. An electron is traveling away from you at 2 times 10 to the 4th meters per second and feels a 5 times 10 to the 8 Newton force, causing the electron to be pushed down. What is the magnitude and direction of the magnetic field? All right? I want you guys to do this one start to finish. So I want you guys to draw the picture. I want you guys to figure out the force, the magnetic field, magnitude, and direction. Okay? George, stop talking, please. Work on the example.
What are you asking?
Example 28. I want you guys to do this one start to finish. Okay? Try it on your own. Okay? Draw the picture. Draw me a picture.
Away from me. So does that mean the velocity
It's traveling away from you.
No, it's traveling away from me.
So away means
Outward.
Away means away.
X.
okay. The velocity is an x.
So it's at the board.
So it's going
Out.
into the board. Out is dots. Okay, think about an arrow. If an arrow is shooting towards you, right? Do you see feathers or do you see a point? A point, right? So the dots are arrows coming at you, right? If an arrow is being shot away from you, do you see feathers or a point? Feathers. So the X means it's going away.
That's why I said outward.
No, it means it's going away. Away from you is this way.
Outward.
No, that's towards you.
I know what I mean.
No.
Okay. It's good because I think what you mean is wrong then.
I don't-
Okay. The
I know
X
I'm not
means
wrong.
into the board.
You're just saying it a different way.
Down.
I said outward. It's going outward, away from me. Outward.
Okay. I got you.
Do you want me to explain to Terry the situations that we had a while ago?
No, I'll explain in a little bit.
Are you sure?
But you have to tell them we don't get chest bursts. That's key fact.
Is it like this, Bert?
Velocity.
This way.
This one's velocity.
And this one.
Okay.
Did you see this?
I'm not sure. Tired. What's up?
Okay. So I've drawn a picture to kind of help you out.
Is that 2 times 10 to the 4th?
Yep.
Why doesn't it just say 20?
Because it's fun making you scientific notation.
Hey, Brett.
Yep.
To take home, if we were to get a picture, what would we do most?
Exam review.
So with the
Wait,
first,
so we got one
because
for
it's
full
I
tree?
can't do it.
Isn't it like this?
The senior test and your test are different.
No, never.
Yep. Trying to get rid of magnetic fields.
So, heat it up.
Maybe later.
Fire.
What are you trying to do?
is it still magnetic?
Get rid of magnetic fields.
Oh,
Yes, it's still magnetic.
Well, then keep going. Go down the stairs, let it roll down.
Put it in like a dryer.
For
I don't know how he does it.
if the force is positive, does that mean it's
What?
the force is positive, does that mean it's up?
Force is positive. Does that mean it's up? No, because the force is down.
They'll show up to school.
So then it says down, it's being pushed down that far. Why do you think we're not doing the work? You already done? Katrina, you're all done too? Because you've been talking.
Yeah.
Okay, George, you're done. I don't see anything in your paper. You don't know how to start out. So that last one you just did?
A day?
Alright, so let's go through it. Velocity is away from you, right? Into the board. So pointer finger goes into the board. Force is down. So, because it says it's got a downward force. Okay? So your thumb points down. So which way is the B field?
Left.
Right.
Wait.
Right.
What?
Okay.
Oh, I'm doing my left hand.
Okay.
That's why.
No, it's not up. It can't be in the same direction as velocity.
Yeah,
There's the force.
velocity's right.
Or in the same velocity's into the board, into the page.
Not it was on yours.
Okay? So velocity's into the page.
So away from
Force is down, right? So B field points to the
Right.
right. Now this says it's an electron. So that means I need to take my right hand rule and
Flip it.
flip it.
Oh.
So,
force is down.
so given the drawing, velocity into the board, force is down, B field to the right. But since it's an electron,
How do you do that?
the B field is actually to the left. You just change the direction when you're done. Okay? So, given what I have, velocity's in the board, force is down, right? So my B field points this way. Right? My B field's pointing to the right. But I'm using an electron, which means at the end I need to flip it, and then I'm done. Okay? So your B field's going the other way. Okay?
I was right.
So the B field is to the
Left.
left. Alright? So now let's figure out what this B what the magnitude is. So the velocity is 2 times 10 to the fourth. The force is 5 times 10 to the negative 8 newtons, right? It's an electron, so Q is 1.6 times 10 to the negative 19 coulombs, and it's a negative 1.6. And we need to find our B. Right?
Yeah.
So, here's the information we have. That velocity is terrible looking. I'll fix it. Velocity is 2 times 10 to the fourth. And the force was 5 times 10 to the negative 8. So that's all the information we have. Right? So using F equals QVB, we can figure out our B. Yes, Kyle?
Is the cube negative?
Yes, negative, because it's an electron.
I see.
Okay. So the force is 5 times 10 to the negative 8 newtons. Okay, newtons there, sorry, equation. Equals negative 1.6 times 10 to the negative 19 times V, 2 times 10 to the fourth, times B. Okay. So let's simplify the right side. Negative 1.6 e to the negative 19 times 2 e to the fourth, and we get 3.2. Negative 3.2 times 10 to the negative 15 b equals 5 times 10 to the negative 8. Right? So what do we do now? Divide. So 5e negative 8 divided by negative 3.2 times 10 to the negative 15, and that equals our b. So we get 1562500 Teslas equals b. Now this is positive or negative? Negative. Okay. Now, let's talk about that negative sign and direction real quick, because I think we're still a little uneasy. All right? So let's talk about our drawing over here. Velocity's into the board, right? Pointer finger into the board. Force is which way? Down. So if this were a positive charge, the B field would be to the
Right.
right. Now, since I'm working with electron, I know to myself, electron, flip the rule. I flip, which means B field to the left. Okay. If you forget to flip that, you're saying B field is to the right. Negative to the right means left. So that negative sign reminds you that your B field is the opposite direction of what your right-hand rule says.
So if it's
Okay?
So
So-
if you put negative to the left, then does that mean you're really saying left?
If you're saying negative to the left, that means it's going to the right. So you can say negative Tesla's right, which means the field's actually to the left. Or you can say positive Tesla's to the left. So the B field is 1562000 left.
If we put it in parentheses, we get what we mean.
What?
Like, if we put it in parentheses like that, like saying that it's going.
That's fine. Okay. Any questions?